Hello everyone, welcome to Legacy IAS. So we'll be continuing with our science and tech. Today we'll be doing NCERT class 6th chapter 6, that is material around us. Now let's see this. So chapter is fairly simple. This is about, see, it talks about the materials that are used to make crucible. Okay, all this is given. Now, so basically it is telling you to observe things around you. Now, one thing that is given here that can help you not in science as such, but it can be asked in a as a history question also. So what is this? It talks about that we have had pottery for a very long time. Okay, now it talks about that from around 7,000 to 8,000 years ago in the Ganga plains, that is Lahura Deva. You might have learned this in, or you might will learn this in history, and in Baluchistan, Mehergarh. So this is where pottery, earliest version of pottery was seen. Then around 4000 BC, wheel turned pottery. What you see as those wheels, no? Correct. That is the modern pottery that you see. Modern means artistic pottery that you see. That is wheel based. Correct. Then in Harappan civilization came bright red surface painted with black color. So this was called red and black ware. Okay. And then it kept on getting better and better. All this you can find in the National Museum, New Delhi. So very simply, it is introducing you to different kinds of materials. Now it says how to group materials. How can we group different materials? So based on some common property, you would merge them, correct? You would group them. Now, see, the first thing it writes is the method of arranging the objects into group is called classification. Very simple, correct? Now, next thing you see here. So it talks about different kinds of balls. This is a tennis ball, then this is a cork ball, we used to call it, or leather ball. Then this is a hand exercise ball, the what you call it, stress releaser ball. So all these are balls similar in shape but made up of different materials. Now now so now it starts talking about different properties of material on which you can group them, correct? First property it talks about is this, which is lustrous and non-lustrous. Lustrous is very simply something which usually has shiny surfaces. Example, metals, correct? Aluminium, gold, whatever you take, all these are lustrous. Then next you come to non-lustrous, which is materials like paper, wood, all that, which do not have any luster or shine in them, correct? Now, so this is first classification, very basic things, okay? Lustrous and non-lustrous. Then the next is soft and hard. This you anyway understand, correct? Soft is materials that can be compressed or scratched very easily. Hard will be something which you cannot do this too easily. Then next it talks about transparent, opaque and translucent. This you understand. So materials can be of three types here. Now, the first is transparent. What is transparent? Like the glass, correct? Beyond which you can see very clearly, the materials through which things can be seen clearly. This is transparent. Then you come to opaque, the materials through which you cannot see at all. For example, I am also opaque body. Can you see behind me? Okay, you cannot. So this is opaque. Then the last is translucent. What is translucent? Translucent is where objects can be seen but not very clearly. So materials through which objects can be seen but not very clearly are known as translucent. Example, butter paper, frosted glass, correct? Butter paper, as in, even if you take a simple example, you take a piece of paper, you rub it on your head, hopefully you have applied some kind of oil on it, then what you will see, the paper becomes slightly transparent, correct? Slightly transparent or not completely transparent is what you know as translucent. Understood? Then yeah, like see, these are all different examples, correct? Then Then it comes to solubility is another way how you can categorize things. So it talks about soluble things and insoluble things. Mainly at class 6 level, they are talking about solubility in and insolubility in water. This is how you can differentiate, for example, sand and sand and let's say salt. This you can very clearly differentiate by soluble or insoluble. Soluble is something that dissolves in water in this case, and which does not dissolve in water. This is sand. Then other properties. See, it talks about ORS also. So this now it is given in NCERT, so you should have some idea. ORS is what? Oral rehydration solution. This was developed by WHO. Now, ORS packets you might have seen, correct? If you don't have, let's say, ORS, how you can make this? It is simply 6 tablespoons of sugar and half tablespoon of common salt. That is needed, correct? Now it talks about there are liquids like oil, vinegar, honey. Do they dissolve in water? So there are actually two kinds of liquids. It is given in some other chapters, that is immiscible and miscible liquids. Miscible is some liquid which will completely dissolve in the other. For example, mm, wine and water. Correct. Wine is completely dissolved in water, so this is called miscible liquids. And immiscible liquids are which don't dissolve particularly with the other liquid. For example, water and oil. Correct. Then what about gases present in water? Yes. So there are some gases that dissolve in water. There are some gases that do not dissolve in water. Example of gas, at least this much you should know. Which gets dissolved in water? Any gas? Yes, oxygen. This is how most of the aquatic creatures survive. That is with the dissolved oxygen in the water. Correct. Then it talks about mass. Mass is a very fundamental property. Correct. Mass is something through which you decide that any object is heavier or lighter. Very simple. You know this. Then it talks about space and volume. Okay. So what is space or volume? So basically, what is the amount of space you occupy that becomes your volume. For example, see this. Yeah. The space occupied by water represents its volume. Simple. Like if you see here how much space it is occupying, let's say half of the bottle is filled, then that much is the volume. Simple as that. Then 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 it defines matter using these two properties. What is a matter? Matter is something that has mass and that occupies space. In other words, which has mass and volume. This is a matter. Now, you have many different units, gram, kilogram, all that are units of mass, and liter, milliliter, all these are units of volume. Correct? And density, or in this case, matter. Matter is a combination of mass and space. Okay. Then next thing it talks about that 1 meter cube is equals to 1000 liter. Okay, 1 meter cube means 1 meter, 1 meter, 1 meter. If you take a cuboid like this, which is one meter on each side, that cube. So what will be the volume of that cube? It will be 1000 liters. Then now it talks about the ancient system, how in the ancient system we used to divide things. So that is in Ayurveda how we used to divide things. So then many examples are given. For example, garu or guru, that is heavy, laghu or light. Then mand, mand aankhein, mand muskana, you might have heard. So this means slow, and tikshana means quick or fast. Correct. Similarly, you have many others. Names are not very important. Then so this is what they talked about the materials that are around us, okay, and their basic classification, correct? Now we get to the next chapter, which is temperature and its measurement. Let's see this. So what it is saying, see, wrong measurements are worse than no measurement at all. Some quote they always give. Now this is a fairly very basic chapter, okay, 1 3 4 points you will get, that's it from the entire chapter. Now, hot or cold, correct, this you measure using thermometers, correct? Then let's see this. First thing it talks about is temperature only. Temperature is what? Temperature is simply a reliable measure of hotness or coldness of a body is called its temperature, correct? Now how it is measured? So it is measured using thermometer. Like you understand speedometer, which measures speed, similarly thermometer, that is thermal, that measures temperature. Simple, correct? Now clinical thermometers, they run on batteries and they work on something that we know as thermal sensors. So they work on thermal sensors, okay, while the old thermometers, if you remember this beauty, okay, they used to have mercury in them, and mercury used to rise with temperature. So earlier you had mercury thermometers which were used for measuring body temperature, but the problem is what? Mercury is extremely toxic and is difficult to dispose of. Okay, one of the statements in a PYQ of UPSC was that about mercury, that mercury is so toxic that it does not have any suitable or any minimum maximum limit for a human, something like this. So basically that was a wrong statement. There are limits, but otherwise, why that statement was given? Because generally it is said that mercury is so toxic that any amount of this is harmful to us. Also it is of no use to our body, completely useless to us, only poisonous. Then after this, now we have started using digital thermometers, which work on heat or thermal sensors, correct? Then then during the COVID-19 you might have seen infrared thermometers also, correct, which send infrared signals to, let's say, your head, and from that they are able to gauge how much temperature do you have. Temperature is what we are trying to measure here, and if you had higher temperature, then they would stop you, okay, and say that we want that no COVID certificate or something for us to let you go. Then the normal temperature for a human is 37 degrees Celsius, or it is also in Fahrenheit scale, it is 98.6 degree Fahrenheit. Understood? Now what are these things? So understand this. The body temperature, if there is an experiment given here, so different students, they tried to test how much is their body temperature. All of them didn't have it, even though they were healthy, at exactly 37 degrees Celsius. Some people are genuinely or in general cooler than other people, and some people are hotter than other people, correct? So both possibilities are there, but it does not vary much. So 1 2 degree here and there can be the different normal temperature of different humans. So it depends upon several factors such as age, time of the day, activity level, all this. Fine. Then another unit. So you learnt about degree Celsius. Then you learnt about degree Fahrenheit. There is another unit called Kelvin. Kelvin is also the SI unit of temperature. So what Kelvin does? So this is the SI unit of temperature. Now how they are connected? So degree Celsius, for example, 0 degree Celsius is actually equal to 270 degree Kelvin. Okay, this is the range we are talking about. Now, then 1 will be equal to what? 274, something like this. Keeps on. The difference is of 274. 273 is the difference between them. Then all three temperatures are named after the scientist who discovered them. Correct? This is what I was talking about. Now, in the earlier times, of course, we didn't have thermometer. Then how do we measure somebody is having fever? So we used to measure the pulse rate of people. If you know, in Hindi, in Sanskrit, you can say there is something called as, not Devanagari, I won't be using Devanagari. There used to be some people called Nadi Vaidya. Nadi means who can measure pulse. So from their pulse, they used to guess that a particular person is suffering from fever or not. Okay, now that is not a very accurate measure, of course, because pulse rate can increase because of anything. Correct. For example, if you run a lot, okay, after that also your pulse rate is higher. So not a very good indicator, but for those times it was fine. Nadi Vaidya, they were called. Now, it is asking you, can clinical thermometers measure the temperature of boiling water or ice? So the answer is no. Why? Why no? Because their range is very limited. See, human beings have to be at 37 degrees Celsius. Now they can be 3-4 degrees Celsius here, 3-4 degrees Celsius here. Beyond that, our body only will not survive. Correct? So they have a very limited range. Then it is asking, how can we measure the range beyond clinical thermometers? So how we will measure? Using something known as laboratory thermometers. Okay, so what it has? It is a long, narrow, uniform glass tube which is sealed at one end, and the tube is a bulb which contains a liquid. So this contains a liquid, and what you will do? Yeah, this actually contains the liquid, and according to the temperature, what will happen? That much it will rise. From that, you get to know the temperature of a particular liquid in which you have put or anything like that. So the liquid in the laboratory thermometer is generally alcohol, colored red to make it easily seen, or mercury. Fine, earlier it used to be mercury, now they have started using more and more of alcohol. Fine, even in labs nowadays, they are using that heat sensor based thermometers. Then how you should measure this? So bulb should not be touching the sides of the beaker. Then it should be held vertical, like he has kept it vertical. The temperature must be read while the thermometer is immersed in water. Then only it will measure the temperature of water. While reading, the eye shall be in direct contact or at the direct line of the thermometer reading. Otherwise, the reading may be here and there. Then now, it also talks about one thing that we'll read in higher classes, that if you take crushed ice and if you take boiling water, even though you will see that the temperature does not change even with time. So more and more ice is getting melted and more water is getting turned into steam, but the temperature is not changing. We learn about this, why such a thing happens. Okay, this is because of latent heat of fusion, vaporization, all that we learn. Then next is air temperature. This also you might have seen. Okay, these are used to give you an approximate idea of the room temperature. Okay, then because weather depends on a lot of factors. That is why what you see is they usually give you a temperature range, the maximum temperature to minimum temperature in a day. Then air temperature is one of the important parameters in the weather. When you are talking about weather, air temperature is the most important thing. This is what you keep hearing, that temperature has become this, that, or that. Then it talks about a scientist called Anna Mani. So Anna Mani ji, what she was an Indian scientist, also called the weather woman of India. Okay, because she made a lot of weather measuring instruments. Understood? So that we are not dependent on other countries. Okay, so this was the chapter of simply measuring the temperature. Then next we come to a journey through states of water. Now, what is this? So basically, like there you learned about temperature, here you will learn all about water. Now, see, first it talks about that different forms of water feels very different. Ice feels very different, correct? Solid. Then water feels very different. Steam, if you get a feel of it, you will feel very different, correct? So basically, you can get burns out of it. Then then it talks about, yes, so gaseous state of water is called water vapor, this you know. Now water vapor is actually invisible, but the presence of tiny droplets of water in the steam make it visible. So H2O, if you look at H2O, now H2O is not a gas which is visible. It is an invisible gas, like most other gases. But what you see as steam, you must have seen a steam coming out. So that is actually tiny droplets of water that are present. Okay, then it talks about the process of conversion of water into vapor state is called evaporation. So it defines evaporation. Then evaporation can take place even at room temperature, not a problem. Okay, evaporation you have seen all around, correct? Drying of wet clothes, correct? Then mopped floor, then sweat on our body, all these are forms of evaporation, correct? Ultimately what happens, you have water droplets that are now gone in the environment, correct? How they're gone? Through evaporation, that is conversion of liquid water to the water vapor is called evaporation. Simple as that. Drying of wet clothes, mopped floor, correct? After mopping for some time, whoever is mopping the floor, let's say you all only mopped it, then you will ask all other people to not set foot on it. Why? Because otherwise it leaves imprints. You just ask them to wait for 5 minutes. Then in 5 minutes, where the water is gone? It has evaporated. Then now, next thing that is relevant is it talks about condensation. What is condensation? Condensation is when you had water vapor become water. See, when water vapor present in air comes in contact with cold surface, it forms water droplets. This is called condensation. Best example of this, for example, if this is a cold bottle, then if I keep it outside like this, after some time what you see? Droplets of water around it. Why? Because that water present in the water vapor is getting condensated here. Understood? Then now this is this is important. So it talks about the amount of water vapor in the air is known as humidity. Okay, so water vapor that is present in the air. Now it also talks about one thing later, that if there is more humidity, if the if the water in the surrounding, okay, if the water in the surrounding already has a lot of humidity, then what will happen? It will not like to absorb more water, correct? So that is why if there is more humidity, what happens? For example, Chennai has a lot of humidity. The problem is now here even your sweat mechanisms stops working well. Why? Because you are sweating, you are sweating a lot because your body is not able to manage temperature, but the air is not ready to take your sweat. The air is saying, I am already filled with a lot of humidity or water, I don't want this from you. So that is why you're sweating so much, but sweat is not getting extracted by the environment. So what is happening? You're just sweating and it is not getting evaporated. And then what happens? You get drenched in your own sweat. Welcome to Chennai. Okay, so this is what we know as humidity. Then Then it talks about different states of water. So there is ice, there is water, there is water vapor. Very simple. Then ice is the solid state, water is the liquid state. It does not have any fixed shape. Correct? Water you put in anywhere, that shape it takes. Then you have water vapor. Now, here what it exhibits a property of spreading out in the entire available space. Correct. So even if you take a small place and here you release water vapor, it will be contained here. But if you take it in a room and here you try to spread it, it will be spread in the entire room also. Correct. So in this case, the water just didn't have shape, but it had a fixed volume. Here the volume is also not fixed. Correct. Whatever space you give, that much it will occupy. So gases, of course, do not have a fixed shape. Water vapor exists even at room temperature, though it is invisible to us. Then, how can we change the states of water is the next thing. So what you can do, so one thing it talks about is atmospheric water generates, AWG. So what is happening? This is experimental right now. So what they do is let's say in Chennai or in any place where there is a lot of humid air. So what you can do, you can have AWGs. Now what this AWG will do, the air that is passing, now this air is very humid, correct? So it contains a lot of water, correct? Now this AWG will try to do condensation of that humid air, and then what will happen, this will become water, and this water can be used in many ways. So this is creating potable water out of water vapor. This is AWG. Then it talks about the process of conversion of a solid into liquid is called melting. This you know. The process of conversion of liquid to solid is called freezing. Very simple. So solid to liquid is called melting, and liquid to solid is called freezing. Similarly, liquid to vapor was called evaporation, or you will learn about boiling also later on. Those are two different phenomena. And vapor to liquid is called condensation. Simple, very simple till now. Mostly we have understood this using water because the chapter's name is around water only. Then how can water be evaporated faster or slower? That is, in very simple terms, it is talking about factors affecting evaporation. Factors affecting evaporation. Now, what factors affect evaporation? What do you think? So, evaporation is affected by, first of all, the temperature. Correct? Let's see what they have written. Okay. Anyway, temperature, then area. See, temperature, you understand how you understand temperature. Just with real life examples, we'll understand. You put your clothes outside in the sun. Now, if it is a sunny day, the temperature is high, the clothes get dried faster. Correct? Then area. Why don't you put your clothes just like the shrinked version? Why you increase the area? Correct? Then only the cloth is dried faster. So area is also directly proportional to evaporation rate. Then can you tell me about wind? If there is more wind, let's say wind velocity. Now, what do you think about wind velocity? How it will impact? See, if it is a windy day, your cloth gets dried faster. If you don't believe this, if there is no sun, like welcome to Bangalore, you don't get sun. So what you will do? You will have to dry your clothes inside. How do you dry it inside? You put it under a fan, a very fan at the full speed. Why? Because you're essentially increasing the wind velocity. And from that, what will increase? Evaporation rate. Understood? So temperature, area, wind velocity, all of these are directly proportional to evaporation rate. Then this also I explained you that it is also a common observation. Clothes dry slowly on a rainy day. On a rainy day, water evaporates slowly. If the amount of, so the last thing is humidity. So humidity is inversely proportional to evaporation. If the humidity is high, evaporation will be lower. As I explained you that in Chennai, the air was not trying to extract sweat out of you or evaporate your sweat. Why? Because it was already filled with water vapor. So you understood all those three things: directly proportional to evaporation. This was inversely proportional. Then it also talks about cooling effect. So what happens? See, this you might have felt with earthen pots. So water seeps through the surface of the earthen pot. Now what happens? See, evaporation evaporation is actually something that generates or that releases energy. So what happens? All these very charged surface layer atoms, they go away. So when they go away, what happens? The remaining part actually becomes colder. Correct? Because suddenly all those particles high energy are gone. So now you feel a cooling effect because of evaporation. This you must have felt. Why? If you go out in the sun, let's say it's a very sunny day, you go out now, you feel very hot. Correct? You cannot live here, you're running. Okay, but if you just continue to stay there for 1 hour, 2 hour, if you continue playing, then after a point it does not feel so hot. Correct? Have you felt this? Then you can continue to play. Of course, you're sweating, but you can continue to play without feeling that much heat. Why? Because your body is able to sweat. From this sweat, you have evaporation, and your body is able to maintain the temperature that is required for you. And also, because of evaporation, what you're feeling? You're feeling the cooling effect of evaporation. Same thing, same is the reason why earthen pots make your water cold. Why? Because there is evaporation, small amount of water is evaporated, but from that, all the remaining water becomes colder. Okay. Then, how do cloud gives us rain? Okay. So how do cloud gives us rain? So this is very simple. So this is a whole cycle. Okay. See what happens. I'll explain you the cycle. So very simply, what happens? Let's say this is a water source. Now, from this water source, water will be evaporated like this. Now, once water is evaporated, what will happen? As it goes higher and higher above the earth, it becomes colder. It becomes colder and colder. Then, at certain height, the air becomes so cool that it starts turning into droplets. Correct? It starts turning into droplets. Now, what will happen? These are usually formed around the dust particle, these droplets. Now, many droplets over a time will join together. Now, once they join together, what happens? Bigger drops are formed, bigger drops are formed, and this leads to eventually it becomes so heavy that the cloud cannot really contain it, and you have something that we know as rainfall. Understood? Simple? Okay. Then under special conditions, if it is very cold high up in the atmosphere itself, it can become hail, that you know as hailstorm, those small icy particles, or snow. I don't know if you have seen. So in the northern part of India, in Himalayas, you may find snow in particular seasons. Then this is the same process, this whole process that I explained you, that water gets evaporated and this then that, eventually what happens? by by rainfall, it comes back in that same water body, and then again evaporation, this that everything goes on. This whole thing is called water cycle. Understood? Then it says only a small portion of water that is available on earth is fit for use by plants, animals, and humans. Correct? That is why we must use water very wisely. Understood? Okay, so this is it for this chapter, that was based on water, the journey of water from start to end. Now, now we come to the next chapter, which is methods of separation in everyday life? Now see. So first is, so basically this whole chapter is about how do you separate things. There you understood how you group things. Then we learned about two, three things, that how you measure temperature, all that. Then we learned about water. Now it is talking about how you separate things. Now see how it works. So first is, it is talking about hand picking. Okay, now hand picking is a simple mechanism where you separate based on size, color, shape of the particles. Correct? Then, for example, you do this with rice. Rice you are separating from the stones using hand picking. Then it talks about something known as threshing. What is threshing? After the crops are cut like this, correct, then they beat it on the ground or on some log like this. This is called threshing. Threshing does what? Threshing, actually, this is the process of separating grains from stalks. So all this stalk is not needed, only this part, which is the main wheat. Even in that, the inside part is wheat, that is needed. So they do threshing. Correct. Now what will happen? Of course the wheat will be there, but also a lot of chaff or waste of this stalks will also be broken, that also will be present. Now how do you separate this? Correct, the separated grain get mixed with piles of husk. Now how do you separate this? Remember this, huh? So this is what you call as supa. Now this is a traditional instrument using which you just take out the light particles from the heavier particles. Correct, this same thing you can do, you have also done with peanut. So you take peanut and the mm, then you just rub it like this, and then the whatever is the peel of that groundnut comes out, and then you can just blow air and it goes away, and then you can eat the peeled groundnut. What is this? Again, because groundnut is heavy, the chaff that you get out of it was light, so you just have provided it air for it to flow away. Same thing is done here also. Now see this, what he is doing with a soup, that is bamboo tray. Husk is on that side because there is some kind of wind, and grain is on this side. Then this process of separating lighter component with heavier is called winnowing. Understood? So you understood threshing as well as winnowing. Then now see, this people get confused by. So this is threshers. Now threshers, they are called threshers. These are a modern machine, but this does threshing and winnowing both. Please remember this. Okay. Then there are also other methods. For example, sieving. Correct. Sieving can do this fine floor particles to pass through the sieve. Correct. So the bigger particles such as bran and small stones remain on the sieve. Correct. Now what you do, you just do like this, the heavier particles or the bigger particles, bigger than the sieve size, will remain up and the other particles will go down. This you use while preparing like uh, any kind of atta, or you want to make roti. So what you do, you first do it like this so that some heavy particles or whatever other remains in the sieve. Then so sieving is used to separate solid mixtures. Then seawater separation. From seawater, what we get? Very famously, we get salt. Correct. We were not allowed to get salt, and then Gandhiji went for a Dandi March, all that. So what you do, basically, you expose it for a few days like this. Then all the water will be evaporated. All the water will be evaporated. What is left is this very small amount of like salts and some mixture. From that, what you will do, you will eventually get out common salt. Fine. Then it talks about Sambar Lake, which is a saltwater lake in India. How you can remember this? Sambar, in Sambar what you have? You have salt, correct? So this is a saltwater lake. Then, then traditional Indian systems. So in traditional Indian systems also we keep doing this, correct? So root, leaves, flowers, seeds of various medicinal plants are often dried up. Then they are This practice facilitates evaporation of excess water, leaving behind the important part of the medicine only. That's why you might have seen Ayurvedic medicines are like some dried leaves, some dried roots, correct? So same thing we also do. Then it talks about another method of separating two things, that is heavier insoluble component from the bottom of the liquid. So this is separation of solid and a liquid. Correct? How do you separate them? Sedimentation and decantation. For example, you take, let's say, muddy water. You take muddy water, what will happen? Mud will get settled at the bottom like this, and you will have water above. Now water you can slowly take out without disturbing the mud below. Correct? So the first part where it is settling down is called sedimentation. The second part where you separate the clean water from above is called decantation. Then this process of separating tea leaves from tea is called filtration. Understood? Then, so what I explained you with muddy water, same thing is done for tea leaves and tea also. Correct? Same way you can separate. So it talks about that. Let's say you don't have seed. Now, how do you take out the tea? So it talks about that you just leave it for some time. The tea leaves, because they're heavier solid particle, they will settle down. Then you can slowly take out from the top. The tea can be taken out without a strainer also. Then same thing, filter, paper, funnel, all that is given. Then you will get mud as a residue. This we already talked about, muddy water separation. Then other than filter paper, many things, for example, cotton, charcoal, sand, these can also be used as filters. Correct? You might have seen those old filters. They had different layers. One of the layer was of rocks, some different kinds of rocks, then sand, then different kinds of soils. All that used to be not soil, but different kinds of sediments of soil that is there, and it used to clean the water. Correct? Same thing. This is also like sea, na? Ultimately, what is sand? It will also have spaces between them. So the bigger particle cannot go through them, but the smaller particle, that is the water, can flow through there. Simple. That is also filtration. Then, then it talks about tea bags. So it tells that tea bags used to be made of silk. Then they found a cloth called muslin, and now they are being made of filter paper. Why? Because it must have the ability to not fall down, but to transfer the properties of tea in the water. Correct? This is what filter paper provides you. Understood? Here you don't have to do any kind of sieving or anything later on, because only the part that was needed from the tea bag, that only is transferred, that is giving the properties to the water, nothing else. Then it talks about something that we know as churning. So what is churning? This you might have seen women or any person doing. So this is the woman. What she is doing? She is churning this. Now, from this churning of curd, what will happen? At the top part, what she will get? What we call in North India as makhan, or you can call it as butter. So she will get butter from the top that she is taking out, and at the bottom, she will have something that we know by the name of buttermilk or matha. Okay, why such separation happens? Why such separation happens? This is because of butter being lighter, it floats on top, while buttermilk being heavier is left behind. Understood? So this is based on weight, or to be more precise, on density. we'll learn about density later on. So whatever is lighter usually will be at the top, and whatever is the heavier will be at the bottom. This is also a way of separating. This is called churning. Then it also talks about magnetic separation. What is magnetic separation? Separation of magnetic and non-magnetic substances by using a magnet is called magnetic separation. So what you have to do, for example, this they do in scrapping. So they take a very strong magnet here and they will move it closer to this entire heap of waste. Now there are, we learned about this in magnet chapter, correct? There are certain substances which are magnetic in nature, for example iron, for example nickel. So if anything is made up of these components, then it will be suddenly attracted to this magnet and it can be separated out, while the other things will remain in the dump, that usually they will put later on after extracting the metals. They will just put fire on it, correct? This is magnetic separation. Okay, so these are the different ways of separating things. Now let's see the summary. So first is hand picking of solid materials based on size, shape, all this. Then you had stocks being beaten, that was thresher. Then you were blowing air on it between lighter and heavier particle, that was winnowing. And then you were doing what? You were doing the sieving operation, correct? To separate the larger particle with the smaller particle, correct? That is called sieving. Then evaporation was done to separate a solid and liquid, correct? What was the solid? Salt was the solid, liquid was water. Then we learnt about sedimentation and decantation. What was sedimentation? Sedimentation was allowing something heavy to go at the bottom. This was sedimentation. What was decantation? Decantation was slowly taking out this clearer part on the top. This was decantation. Then we also learned about filtration, separating solid and liquid things, correct? That tea example. Okay, all that can be done. Then we learned about churning. Why is churning important? Because churning is used to extract butter from the curd, correct? Same process, you are doing this, and because of that the lighter particles will come up as butter, correct? Butter is considered milk solids, so that is actually separation of solid and liquid. Fine. Then the last was magnetic and non-magnetic substances being separated using simply a very strong magnet. Understood? Then see, it is asking you to play these games. Okay, it is asking you some questions, that which of the following substances can be separated using churning method? So churning method, cream from milk, same logic. Then what purpose this? Hand picking, sir. So picking is for sorting, this is for cream from milk. Then what factor is usually essential for filtration? What is essential for filtration? The pore size, correct? Then only you can separate. Then salt can be separated from salt solution by keeping it under the sun. Yes, correct. Water will be evaporated. Hand picking should be only used when the quantity of one component is less. What do you think? Yes. If they're both equal, then it is of not much use. Correct. Essentially, you are separating two things. Then you have more rice and less of stones. Then only you are doing separation. A mixture of puffed rice and rice grains, okay, can be separated by threshing. Yes. Why? Because puffed rice, if you remember, is like poha that you eat, that is very light in nature. So do you can separate them like this. Then next is a mixture of, no. So this is saying threshing. No, this can be done using winnowing. This is not threshing. Then a mixture of mustard oil and lemon water can be separated by decantation. Mustard oil and lemon water. See, ultimately, don't get confused. This is oil, this is water. Can you separate them using decantation? Yes, they will form two different layers. But so you can use a separating funnel or you can slowly separate them. Though it will be much more difficult than doing it with solids, but you can try for this. Then last is this. Sieving is used to separate a mixture of rice flour and water. Rice flour and water, can you separate by sieving? Yes, you do it every day. When you're washing rice, you're using your sieve and you are separating rice and water. But it is asking about rice flour and water. Okay, so now this also can be separated using sieving. Yes, rice flour and water, but it will get mixed up completely. So rice flour and water using sieving. So sieving, if you do, there is rice flour, there is water. Okay, it depends. It depends. If the rice flour you have already mixed it with water, then it becomes very difficult to separate it using sieve. Why? Because it will become like a whole solid. Okay, then this is separation of different things. Hand picking, what is hand? So gram flour mixed with black gram. Okay, then chalk powder mixed with water, corn mixed with potatoes. This is fairly easy. You have to just match it with the second column. Okay, then some more exercises. All that are for children. You are fine with it. This is it for this lecture. We are done with the 3 chapters. Thank you.